Assuming the Earth to be a sphere of uniform mass density, how much would a body weigh halfway down to the center of Earth if it weighed 250 Newton on the surface? So the weight of the body on the surface is given to be 250 Newton. And this value 250 Newton is equal to m into g, which is m into g me by re squared. Let's write the value of me in terms of density. So me will be equal to density times the volume, and the volume of the sphere could be written 4 by 3 pi r cube. If we substitute back, we are going to get m by re squared g into rho times 4 by 3 pi re cube. So this is going to be equal to 4 by 3 rho g m pi re, and this expression and this term is given to be equal to 250 Newton. Now let's calculate the weight of the body when it is kept inside a tunnel which is having a depth of half the radius. So let's say this is the Earth, and we have dug a tunnel of half the radius. Distance is r by 2, and we have kept an object inside this tunnel, and we would like to weigh this object. Now let's divide this Earth as two objects. They are the hollow part, which is outside this boundary, and the solid part. So there are two parts of the Earth which is contributing to the gravitational force on that body. The hollow part, this one, and there is the solid part. We already know if we place a body inside a hollow sphere, the force on this body is going to be zero. At any location inside this hollow space, at this point, or any point on the surface also, the net force, the net gravitational force on the body is going to be zero. So the hollow part, which is this part, does not contribute to the gravitational force on the body. So the only part of the Earth which is contributing to the gravitational force is just the solid part. This contributes. So we can draw the equivalent diagram for this as some planet which is having the same density as the Earth and having the radius r by 2. And we have placed the body on this planet's surface, and we are weighing the body. So the gravitational force Fg on this body is going to be g mass of this particular object, let's say it is mp, and mass of the body by the distance between the center of masses of this planet and the body, which is r by 2 squared. As the density is same as that of Earth, we also write mp in terms of the density. So this mp could be written as density times the volume, and the volume is 4 by 3 times pi into Re by 2 cube. So if we substitute, we would get Fg, which is the gravitational force of the body when it is placed inside the tunnel, as G by Re squared by 4 into m into rho into 4 by 3 pi Re cube by 8. So this comes out to be half of 4 by 3 pi rho g rem. This term, we already found out that this is the gravitational force on the body when it is placed on the surface of the earth, and this is already given as 250 Newton. So this comes out to be half of 250, which is 125 Newton. So 125 would be the weight of the body when it is placed inside a tunnel having depth half of the radius of the earth.